So this time we're talking about 2.2 transformers more than meets the y's. So our objective today is to be able to, I can graph parabolas in vertex form. So vertex form is just a form of how to write a quadratic equation or a quadratic function. So this equation that you see right here in the middle, that is vertex form. And all of these things, the A, the H, the K, they all represent different transformations that have happened to our function. And so we want to write down, we want to know what each one of them actually does. So the plus minus part tells us the direction of whether our parabola is going to be opening up or opening down. So if it's a plus, it's going to be opening up. And then if it's a minus or a negative, it will be opening down. So it depends on what A is. If A is going to be positive or negative, that will tell us the direction of where our parabola is going. So then A itself, if you played around with this a little bit on your graphing calculator last time, you'll remember in 2.1, but this stretches our graph, so it makes it wider or taller or shorter. And so it depends on if A is bigger than 1 or if it's smaller than 1. So this is a dilation factor. It will tell us how much our graph has been dilated. So it's going to be a vertical stretch if A is, or the absolute value of A, it doesn't matter if it's positive or negative, but a vertical stretch if A is greater than 1, and then it's going to be a vertical compression, or gets smaller, shorter, compression, if the absolute value of A is less than 1. So fraction, decimal, 0.5, or 1/2, or 1/3. So the H is a shift right or left, and insiders are liars. So this is actually going to be opposite of what you think it's supposed to be. So it's going to shift to the right if it's a minus on the inside of this, because the minus is already part of the formula. And then it's going to shift left if it's a plus sign. And then K will be a shift, but it'll be a vertical shift. So it's either going to be up, and this is what you think it will be. So if it's a plus, it's going to go up, and it'll be down if it's a minus sign. And all of these transformations are based off of the equation y equals x squared. That's our basic function. Y equals x squared. That's our parent quadratic function. So we can plug in all of these x values. So -4 squared is 16, -3 squared is 9, -2 squared, so on and so forth. And the square is what makes everything positive, because if you multiply any number times itself, there's no way you can end up getting a negative number. And 16. Okay, and then, looking at this vertex form again and all of these different transformations, we will be able to tell the vertex by if it's been shifted right or left or up or down. So just by the shifts, because usually the vertex is at 0, 0, but if it's shifted right, we have to take that into account, and then shift it up or down, we have to take that into account. So H right up here, that will give us the X value of our vertex, and K will give us the Y value of our vertex. And then the axis of symmetry, so the kind of the mirror line that we'll see is that X equals H. It runs straight through the vertex. So now let's look at some examples. So looking at this example right here, we're going to identify some things before we graph, and then we'll go back and forth. So here, just looking at our function up here, A, this number right in front, is 2, right in front of our parentheses, and that will tell us a couple things. Remember, so in this case, A is positive, meaning our parabola is going to open up. So it'll be like this type of shape. And if it opens up, that means our vertex down here at the bottom, we are going to have a minimum, because it has a point where it goes lower, but then it goes up forever. So there is no maximum, but there is a minimum point. So minimum So if it opens up, it always has a minimum. The axis of symmetry is that x equals, and we have to look for h up here. And remember, insiders are liars. That's what I like to say. So insiders are liars. It's going to be opposite of what you think on the inside. So that's actually going to be a -1, that h value. So our vertex pulls that same x value and then pulls the y value from the vertical shift on the outside, which is -8. And that just stays positive or negative, whatever it is. The y-intercept, so this one, we always know the y-intercept on any function ever has an x value of 0. So if you have an equation, all you have to do is take that 0, plug it in for x, and then solve, and that will give you your y-intercept. So for us, 0 plus 1 is 1, 1 squared is 1, times 2 is 2, minus 8 gives us -6. So for our y-intercept. And I'm going to actually wait on the one additional point after we graph. So coming over here, I'm going to graph our axis of symmetry, which is at -1. So that's our mirror. So I'm going to run this line straight through x equals -1 because I know it's going to be a mirror image on either side of that. My vertex is at -1, -8. So I'm going to graph that. And then our y-intercept is at 0, -6. And here is where we can get our second point. So I know my axis of symmetry is the mirror line. So I'm going to graph this point right on the other side. And so that I can say -2, -6. That is my additional point, -2, -6, because that is a mirror on the other side. And then you can connect your dots. And remember when you're connecting your dots for a quadratic to make it always a curve. It's never connected in straight lines. So there's our first example. We're going to do the same thing with example 2. If you want to pause the video and try this first, see if you can come up with the graph and everything on your own, that would be awesome. So this time our A is -1/4, the number in front of the parabola. And this time it's negative, so our parabola is going to open down. So if you want to sketch like this, it's going to open this way, meaning our vertex is going to be at the top. So it's going to be a maximum. The axis of symmetry is at x equals h, which for us, this number on the inside, insiders are liars, so it's going to be -2. Vertex uses that very same x value and then uses their y value on the outside, the +5. The y-intercept, we're going to plug in a 0. So 0 plus 2 is 2. 2 squared is 4. 4 times -1/4 gives us -1 plus 5 gives us 4. And let's graph so we can find our additional point. So I do my axis of symmetry first, which is at -2. So run my dashed line down here. The vertex was at -2, 5. So starting here, maximum is going to be there. Y-intercept is at 0, 4. So then I can reflect that across the axis of symmetry. So -4, 4 is going to be my additional point. Or you can find additional points by just plugging in more x values if you want to do that. Oop. Make sure it actually goes through your point. There we go. And it looks pretty curved. Okay. So now moving on to the back side of the notes, we have a follow-up question. So it's asking about x-intercepts. So talking about x-intercepts, how many x-intercepts are possible? So we're going to take y equals x squared and y equals -x squared, and we're going to do some transformations to see if we can change how many x-intercepts we have. So looking up here, we're looking for where it crosses the x-axis. That's the x-intercept. So here we have 2. We ended up having 2. Here we ended up having 2. But there are more options than this. So we know that 2 is an option. So x-intercepts, number of x-intercepts. We know that 2 is an option based off of our graphs above. Okay, so 2 is an option. And let's actually do some changes. So here's our x squared graph. Oh, and look, even before we do any transformations to it, how many x-intercepts does that have? And the answer is 1. It comes down, it touches the x-axis 1 time. So we know 1 is also an option. So we're going to put that here. 1 is also an option. I'm going to do some pictures of that later. But let's see if there are any other options. So let's do some transformations. So if I minus 3 to this graph, now I have shifted it down. So now I have 2, but I already knew that I could do that. So let's maybe shift it the other way. So let's do a plus 3 instead. So I shifted it up. How many x-intercepts do I have now? And the answer is 0. It never crosses the x-axis. So if I flip this upside down, so maybe let's try doing negative. So now that I've reflected it and now it opens down, now I have 2 again. But then I can shift this, maybe if I shift it down. So negative x squared again by itself just has 1 x-intercept, and then I can shift it down to have 0. So it just depends on if your function is opening up or down, your parabola is opening up or down, and which direction you shift it. And it doesn't matter if it moves right or left, actually. It only matters like the up or down shift. So looking at y equals x squared, an example of what x squared would look like opening up, having 2 x-intercepts would look like this. Having 1 would look like this. It would just come and touch and pretend like that touches. We'll say it touches right there in the middle. And then if it has 0, that means I would shift it up, so it never touches the x-intercept. So looking at negative, so if it's upside down, like this one, to have 2 x-intercepts, I would have to shift it up. To have 1, I would not have to shift it at all. To have 0, I would have to shift it down. So those are our possibilities of transformations and creating different numbers of x-intercepts. On example 4, so we've talked about vertex form this whole time, but we also have another form that is called standard form, and the equation looks like this. So when it looks like this, we have to be able to identify what is A, what is B, what is C. So for us, if you notice, A is right in front of x squared, and these are numbers. We're trying to find the numbers of this situation. So we want to know what's the coefficient, or the number in front of x squared. That will be my A. The number in front of x, or the coefficient of x, that will be B. And C is the constant. It's the number hanging out by itself with no variable at all. So for example, on part 1, A, again, is the coefficient of x squared. It's the number in front. So for us, this will be 5. B is the coefficient of x. So that's a positive 3. And then C is our constant, which is a positive 6. So pretty easy if you know what to look for. On part 2, it's not quite in standard form yet, so we have a little simplifying to do. So remember, when you square something, it means that something, whatever it is, times itself. So we need to write this out as x minus 2 times itself. And then we need to actually multiply that together because we are not in standard form. So when I multiply that, I get x squared minus 2x minus 2x again plus 4. And then I can combine like terms. And now I'm ready. I have my x squared term, my x term, and my constant. So now I can say A, for me, since there's no number in front, that's always going to be a 1. Since it's there, I have 1x squared right there. B, our coefficient of x, is negative 4. C is our constant, and that's positive 4. In part 3, we don't have all of the terms. However, we can still identify A, B, and C. There's nothing we can simplify or multiply together, but we still do have a coefficient for our x squared term, which is negative 2. We have a coefficient for our x term, which is 1. And then C is the constant hanging out by itself, and usually it's over here, but we don't have anything there. So the number to represent nothing in this case, and additive nothing, is 0. Because if I put a plus 0, that won't make a difference. It won't change the value. So we can say C equals 0. All right, our very last example, example 5. we are using this table instead of a graph to identify the vertex, the axis of symmetry, how many x-intercepts there will be, and if the parabola has a maximum or a minimum. So this is a table from a quadratic function. And so we are trying to find all of those things. So first we need to identify the vertex. And remember, the vertex and the axis of symmetry is kind of where everything is centered around. So if you notice on the y values, we have like 14 and 14. So those are matching. These are matching. These are matching. These are matching. So it looks like it's all symmetric or centered around this point right here. So that is going to be our vertex. So our vertex is the point 0, -2. Our axis of symmetry is the line that runs straight through that point, so we're going to use the very same x value. And now we have to think about, okay, not looking at the graph, can we tell still how many x-intercepts there will be? So you just have to look at your y values because that tells you where your function is, how tall it is, if it's above the x-axis or below the x-axis. So we start at 14 for our y value, and then it goes down and then down and then down. It actually goes from positive into negative numbers. And so that tells us that it does cross the x-axis at one point, and then it even crosses again because it goes from negatives back up into positives. So for x-intercepts, we are going to have 2. And then since we know it goes from higher down to lower, so our vertex is the lowest in the middle, we know that we are going to have a minimum because it's at the lowest value instead of at the highest.